A coil of resistance 60 ohms with 2000 turns and cross-sectional area of this number is connected to a galvanometer. When it is rotated through 90 degrees, in 0.25 seconds, a peak current of 10 microamperes is generated. What EMF is induced in the coil? So it looks like we have a generator here. We have a coil that's turning through a magnetic field in a certain amount of time and producing a current. So if we want to figure out the EMF in the coil, what equation do we need? V equals IR, of course. So what are those three values here? Well, V is going to be our EMF, so that's the unknown. I is the current, so that's given by 10 microamperes. And R is the resistance, 60 ohms. So what will we get here? Once we substitute everything in, we'll end up with 6 times 10 to the minus 4 volts, or 0.6 millivolts. 1 millivolt is 10 to the minus 3 volts. Part B, what is the magnetic flux through the coil? So we have a EMF produced. What we need to do is use this EMF in a different equation that will tell us the flux through the coil. So our equation here is, of course, electromotive force equals number of coils times the change in flux over the change in time. So the change in flux will be our initial magnetic flux, which we're trying to find, minus the zero of when the coil is parallel to the field lines. So this will be our unknown number, maximum flux. N is known, electromotive force is known, and T is known, right? So we can rearrange our equation so that now it looks like this. Substituting in our numbers, we have 0.6 millivolts times 0.25 seconds over 2000 turns. And we can use a calculator to evaluate that too. 7.5 times 10 to the minus 8 Tesla meters squared. Now you'll notice in this question that there haven't been any magnets mentioned. In all likelihood, the amount of flux passing through this coil is due only to the magnetic field of the Earth.